Greetings and welcome to BeIndie.biz. My name is Alan Thorn. I've been a game developer for the past 20 years and love helping people learn how to make games. In this movie, I'm going to show you how to use the GI probe system right here in the Godot Engine. This is a great system for creating high quality lighting results for your 3D scenes. Now, the Godot Engine has two different lighting systems and you need to use one of them and make a choice. We have the light baking system. We have a tutorial covering that. That's a great option if you want to choose good looking lighting that works on a range of different hardware, from really old hardware to new hardware. But in this tutorial, we're going to be looking at a very high quality system called the GI probe system, Global Illumination system. And this is for creating lighting that works on high-end hardware, console style hardware, desktop hardware. It's not really going to work well on older hardware, but it does achieve really great results with complete reflections and diffuse interreflections. In short, the GI probe system that we'll see in this tutorial is the option you want to choose for creating the highest quality lighting results here in the Godot Engine. In this tutorial, I'm going to show you step by step how to start from practically nothing and how to build up a scene that's going to work well here using the GI probe system. So let's get started in this tutorial, creating lighting using the GI probe system. As mentioned, this system is for creating some of the best quality lighting that the Godot Engine can offer, but it's performance intensive. Now, to demonstrate this system, I'm going to begin here with a Cornell box scene. You can download this project file from the link included in the video description. It's pretty much an empty Godot scene that I've already gone ahead and configured here. We have pretty much a box inside a box. Now, each of the walls and the ceilings and the floor of this box have different color materials. So for example, here we've got a blue floor, a green back wall, the red side wall here. These are all based on the theme that runs through the Cornell box. Now, the Cornell box was developed in Cornell University, where they were exploring lighting systems in computer graphics. In this scene here, you can see that we have a prop, this cube, at the center of this room. And as you see, when we're going to build up the lighting inside this scene, you'll see the different reactions we get from the surfaces in this scene. So I'm going to be setting up the GI probe system to illuminate this scene that we have right here. Now, this scene has the default lighting applied, and you can see inside the hierarchy panel here, inside the scene tab, we have pretty much just a few meshes, and that is basically it. Now, the really strange thing about this scene is that it comes with a sky for an exterior environment, and actually we can see all of these objects. If you take a look at the scene, we have no lights at all, so actually everything should be completely black, but that's not what's happening. The reason for that is because Godot has applied some default lighting to this scene. So actually, even when you create a completely new and empty 3D scene, lighting is already taking effect. If you want to get the most control over your lighting, we need to find out how to access these settings so you can change them. Now, to do that, we're going to create a new environment object. I'm going to move to the scene tab here, right click on the scene root and choose add child node to display this child node section. And I'm going to be adding a world environment. I'm going to select that object from the list and then choose the create button here to add that to the scene. Now, by default, the world environment object is pretty much devoid of any information. If we take a look at the inspector here and we expand the environment tab, you can see it says empty, but we can just click on the drop down here, choose new environment, and bang, straight away, the moment that I add a new environment, take a look at what happens inside the scene. Everything turns completely black. Now, the reason everything turns black is because this environment node that we have just added is completely overwriting the default information that Godot was applying to our scene. All that default lighting, gone. It's been replaced by this world environment node, and now we have complete control over the environment lighting in the scene. Perfect. I'm going to expand the environment node here and just expand the ambient color field. I want to make sure that the ambient color is set to black. Notice if I set that to white, we have complete white permeating the scene and illuminating everything. We have this bright white light shining in every direction, illuminating everything, and it looks terrible, absolutely terrible. So I'm going to drag the slider back down to black to completely subtract all ambient lighting from the scene. I want to have the direct and indirect illumination controlled entirely by the lights in this example. So I'm going to remove all of that data. You want to make sure that is set to black. Now the next thing I want to do is to add a light into the scene. Well, that's pretty simple. I'm going to go back to the scene tab, right click on the root object, choose add child node, and I'm going to be adding a light. We have a choice here of directional light, omni light, or spotlight. I'm going to be choosing the omni light, which effectively casts illumination in all directions. So it begins from this center point here and casts light outward for a particular distance. So I'm just going to position the light, and I'm going to position it maybe just about here, like so. Now, in some instances, you might think, well, that's all we have to do, but you would be wrong. You can't just drop a light into the scene and expect the illumination to look good. Lighting in computer graphics simply doesn't work that way. And we can see a clear example of that right here in the viewport. I have dropped this point light or this omni light into the scene, and we're getting some illumination. You can see that on the cube here. We've got some lighting coming from the omni light, lighting up that cube. Perfect. But notice that this side of the cube, the side facing away from this light, and actually if I rotate my view around to take a look at these two sides, they're facing away from that omni light, and they are completely black. Now, lighting in the real world doesn't work like that. It, first of all, is cast from the light. It hits a surface, let's say this wall here, and bounces off of that surface and hits the backside of this cube. So what that really means is that this backside of the cube shouldn't be completely black. There should be some bounce lighting on that cube. That's known as indirect illumination. Now, the reason that this is happening is because by default, these lights will only calculate direct illumination, and that's it. The GI probe system that we're going to be adding will calculate the indirect or the bounced lighting for us automatically. So I'm going to be adding the GI probe system. Now, before I go ahead and I do that, I want to select all of the meshes in the scene. So I'm going to be selecting the Cornell box object here. That's the environment object. I'm going to move to the geometry instance tab. This is a mesh object. I want to make sure that I activate the use in baked lighting checkbox. I want to make sure that's ticked on. If that's not switched on, this object is not going to be affected by the GI probe system. I'm going to do the same thing for our cube object here. I'm going to make sure used in baked lighting, that's switched on as well. So both the prop and the environment have that option activated, and that means that when we add the GI probe system, they're going to be affected. Now, to add a GI probe object, again, it's really straightforward. You just move to the scene root here, you right click and choose add child node, and I'm going to search for GI probe and select that option and choose create. Now, as I add the GI probe object, it appears as an enormous cube, basically. And I want to make sure that this cube surrounds my environment. This should represent the entirety of the region in our level that we want to be affected by the GI probe system. Now, in this case, I have these handles, these red handles, that I can click and drag on to resize the GI probe to fit the environment. Now, sometimes these kind of get tangled up with these arrows here. So if you want to tweak the size, you can also move over here to the extents setting to begin to change some of these values. So I'm going to just use the settings here in the inspector. So I might set that up around about there. And do a similar thing for the y-axis. I'm going to use the translate tool, the move tool here with the W key to kind of bring the probe further up into the center of the level so that as I tweak the Y parameter here in the inspector, it's going to center in on that level. So maybe somewhere around there and kind of center that object up. I want to make sure that the environment's completely contained within the boundaries here. I'm going to do the same thing for the Z axis and maybe something kind of like this. So that's looking pretty good. We've now got this cube assigned and centered around the scene. I'm going to zoom in just a little bit to the scene here. You can see the subdivisions of this grid here. And we'll see in just a second how that works. Now, in positioning this object, I want to move to the top here, to the button in the viewport that says Bake GI Probe. Before you go ahead and click that button, make sure that you save your scene. I can tell that my scene isn't saved simply by moving over to the name of the scene here. You'll see the little asterisk here to indicate that it's not saved. Just press Ctrl S or Command S to save that scene, and then choose the Bake GI Probe button. Now, in doing that, you can see that some really important changes have been made, but they're kind of hard to see because we've got this grid in the way here. Now, you might think that you could actually just hide the GI Probe by deactivating it here, but you're going to deactivate the results inside the viewport. Instead, you want to choose View, Gizmos, and then move down to GI Probe, and you can deactivate the visibility of the probe here inside the scene so that I can't in fact see the probe. Now, when I take a look at the probe here inside the scene, you can begin to see, and you can see here that suddenly the face here that was initially black, in fact I can deactivate it to show you the before and after, you can see that although this was completely black, by reactivating this now we're actually getting lighting here. I'm going to move to the other side and you'll see a very similar thing. Where we previously had black, we no longer have black because it's calculating that indirect illumination. That's pretty good, but still there's this kind of weird banding shape here that we're going to adjust in just a moment. Now, the next thing is that this is an interior scene. So we have some optimizations that we can apply to the GI probe to optimize for that. If I move over here to the inspector panel, I'm going to activate the interior option, and you can see that in doing that, it's conserving more energy as it's bouncing around the scene, and the intensity of the lighting for this interior scene increases. In addition to this, I want to move over here to this setting here. You want to make sure that both the bias, the bias setting is 1 or greater. If you go below the value of 1, you're going to get some strange artifacting on your lights. You can see here, even I've got some strange artifacting on the side of this cube here that I kind of want to get rid of. And I'm going to be using that by tweaking the normal bias. I'm going to set that to 1.2. And in changing that to 1.2, see how the quality of my lighting for this interior scene has radically improved. So if you get some of that banding or that artifacting on your scene, you want to make sure that you tweak the normal bias. So you can see here already, straight away, we've got this illumination in the scene. We've got bounce lighting hitting this green wall. It's bouncing from that green wall, and you can see that it's tinting part of the surface of this a green shade. It's matching the color of that wall. We've got a similar thing going on here, the light bouncing off the red wall and hitting that cube. Really similar thing going on. Now we can also increase the energy and the propagation. These two settings can increase the brightness or the intensity of the light inside this volume. I'm pretty happy with how this is looking. I could maybe go ahead slightly further and just bump up the brightness just a little bit, and you can see the effect that is having. I'm just going to rebake my GI probe. Very often you won't need to do that unless you really radically change some settings, as we'll see in just a moment. Now you can see that not only do I have these diffuse interreflections of different colors bouncing off, but if you look at the walls here of this environment, you can see that it's also giving us reflections. We have these really shiny surfaces, and we can see the reflections in this. Now you can try to improve the quality of the reflections and your illumination by increasing the subdivisions of the cube. If I go back to take a look at my GI probe cube here inside the scene, you can see that I can change the subdivision settings, for example, to 256, and then choose Bake. That's increased the intensity of the subdivisions of the cube. Let's just hide my GI probe. I don't really need to see that anymore. And in doing this, you can try to improve the quality here of your reflections by increasing the subdivisions of the cube. I'm just going to switch that all the way back to 64 and rebake. You can see the effect that's having. Now in doing this, we're increasing the performance. We're getting better performance because we're using less subdivisions on the GI probe cube, but we're also here reducing the quality of the reflections and the diffuse interreflections. So you will need to tweak several different settings on your GI probes for your scenes, and every scene is different. It's different in terms of the objects you've got, different in terms of the size of the scene, you will need to tweak fundamentally the subdivision settings and these bias settings here to get the best results. If you're creating an interior scene, make sure to activate that interior checkbox. So this is the fundamentals of how we get the GI probe system working. Now you may be wondering about these reflective surfaces here. For example, the red wall of that cube, really very, very reflective. Now part of this is also controlled by the materials in the scene. So for example, I'm going to take this red material, double click on it to select it. And it has a range of different properties that are going to be controlling the reflectivity of that surface. The first one is down here in the metallic field. You can see we have this specular slot here that controls the shininess of this surface. I can slide that all the way to the top to increase the shininess, and you can see the change that makes in here, or I can move it all the way back down to the bottom to reduce the shininess. But actually, if you look carefully, even in reducing the shininess, there's still reflectivity going on. You can see the top of the cube here reflecting on that red wall. Now the reason for that is because of the roughness parameter down here. This tells us how rough or smooth our surface is. At a setting of 0, this is a perfectly smooth surface, just like a mirror. So I can increase the roughness of that surface to break up the reflections on that wall. And you can see now we can hardly see those reflections at all. I could revisit the other walls to change their reflectivity properties too. This red wall on the other side shares exactly the same material, so that's lost its reflectivity too. I could change this back to, for example, 0.5 to increase the shininess. You can see a bit of the reflectivity there, and then reduce the roughness to again make this practically a perfectly smooth surface. So with a combination of these different parameters, we can create a GI probe system that gets us great looking results. Now, one of the interesting properties of the GI system that distinguishes it from the baked lighting system is that it's dynamic. It's in real time. The objects we've added so far, this cube and this environment, we selected each of these objects and we marked them as used in baked lighting. When we do that, the GI probe system can perform optimizations. So it can pre-bake a lot of the lighting for these objects because it knows they're not going to move. If we did something like take this cube and move it, in fact, let's just take the prop cube and move it, we would need to rebake the lighting by moving back to the GI probe object and selecting rebake to update the lighting on that scene here, like so, because we've moved the object. But if we added an object that moved, for example, a completely dynamic mesh, it's still going to receive indirect illumination and update in real time. Now that's pretty performance intensive, but we can still do it. Let's take a look. I'm going to move to the root tab, right click, choose add child node. I'm going to add a mesh instance here, and I'm just going to bring the mesh up into the level and move to the mesh tab, and I'm going to add, let's say, a new sphere mesh. And now in doing that, notice that so long as this sphere is inside the GI probe volume, it's receiving direct illumination from the lighting, but it's also detecting the fact that, for example, it's near a red wall. You can see the diffuse reflections shining on the rear side of that sphere. Notice it's going to be a very different case if I grab that sphere and take it outside of the GI probe volume. When I do that and I remove it from the GI probe system, suddenly I see what this sphere would look like if we didn't have the GI probe system. We would have the direct light from the light here. You can see that illuminating the sphere, but then afterwards behind it, completely black. Contrast that to putting it back into the GI probe system, and now we're getting direct and indirect illumination on that sphere, making it look much more realistic. So if you do something like move one of these objects here, the static objects, the cube or the walls here, objects marked as used in baked lighting, then make sure that you select the GI probe and rebake whenever you move a static object. But during gameplay, if you do something like move the new sphere that we created, that doesn't require a rebake. That's going to be updated in real time, showing us the raw power of a real-time lighting system. This is a really amazing global illumination system, but be careful. because it requires a lot of power. So your gamers, your players are going to need to have a pretty powerful system to get the best results from GI probes. This has been Alan Thorn at BeIndie.biz. I hope you found this tutorial helpful. I'll see you next time for more tutorials.